today, for this morning, we are gonna get started and discuss the system development process. And as I mentioned, we went through the main steps of the development process already. Today, we're gonna start looking at the details within each area of this of each stage of the process. And this is material covering chapter 4 of your textbook. So I encourage you to look at the textbook, read the chapter, so you get a deeper understanding on the material that we are going to be discussing today and on the next lecture. So systems engineering through the system lifecycle. This is the agenda for this morning. System lifecycle, and also we're going to discuss the evolutionary characteristics of the development process, and finally the systems engineering method. So this lecture is devoted to describing the basic steps or the basic system development process and how systems engineering is applied at each step of this process. A typical major system development exhibits the following characteristics. It is a complex effort, and this is one of the questions that I got via email. How do I know that I'm choosing the right system for our project? So among the characteristics that were described in the project description, this can help you also in making sure that your system is achieving those characteristics that are required for a complex system. It meets an important user need. So this is something that is needed. This is just not something that you are coming up because, I don't know, for example, a new lighting system because I don't like the color of the lights. No. It has to meet an important user need, specifically for the society. It usually requires several years to complete, so this is a major effort. It's not something that you can sit down and complete in one day. It's made up of many interrelated tasks. It involves several different disciplines, so it's a multidisciplinary effort. It is usually performed by several organizations, like we saw for the 787 case study, that you have companies providing you with some of the components and so on. And it has a specific schedule and budget. Okay, so a major system development exhibits the following characteristics, and those are listed in this slide. Any questions? And look at the last one. This is something that we've been discussing over and over again, making sure that we are on schedule and we are within the resources that we have available or the budget. So the system has to perform to a certain level, but you have to make sure that you're meeting the schedule or the deadlines and you are using the resources that you have available. So the system development must be conducted in a step-by-step manner in which the success of each step is demonstrated and the basis for the next one validated before a decision is made to proceed to the next step. So even though this is going to be an iterative process, we need to make sure that in order for us to move from need analysis to concept exploration, that we have meeting some of the goals that are required for us to move from one step to the other. So we need to have some type of validation in order to move forward with the developmental process. So what is the system life cycle? The term system life cycle is commonly used to refer to the stepwise evolution of a new system from the concept through the development and onto the production operation and finally its disposal. Okay, so when we are designing, we are creating this new system, we have to go through this whole cycle. The role of the systems engineer changes accordingly, depending on what step of the process or the life cycle you are. The system life cycle is based on 3 different sources. And these are the sources that we've been using so far: the Department of Defense Acquisition Management Model, the International Model ISO IC 15288, and the National Society of Professionals model, Professional Engineers model. Okay, so these are based on this system engineering lifecycle is based on these three different sources. And I think I have mentioned these three before in one of the previous lectures. So let's look at some of them. This is the DoD acquisition management model. And as you can see here, there are multiple phases. This is tailored toward managing large, complex system development efforts where reviews and decisions are needed at key events throughout the life cycle. So in this diagram, you see there are some boxes that are disconnected, and then there are some boxes that are next to each other. And for those boxes that are connected to each other, there are some figures that are used. They have some meaning. For example, this triangle, it requires, basically what that means is that for the system to continue its development in this life cycle, you have to perform a review. So there are 4 reviews or 3 reviews in this case, A, B, and C. One review is required from material solution analysis to development technology. Okay, so a review must be performed from here at this point after you are done with this phase before you can go and move forward with the next step. So that's what we are trying to say on this first bullet. This is tailored to managing large, complex system development efforts when reviews or decisions are needed at key events through the life cycle. The major reviews are referred as milestones and are given a letter designations, in this case A, B, and C. And those are the ones that are here at the top. So for example, at milestone A, a requirement document needs to be approved by a military oversight committee before a program will be allowed to transition to the next phase. And these are one of the differences from this cycle model from the others that we are going to discuss. So you can read through these boxes. I mean, the idea is that this is guiding you through the overall cycle of the system design. So from technology development, engineering, manufacturing development, then you go to production and operation and support. And these phases are divided into 3. You have the pre-system acquisition, and when you move from here to here, you have a review. Then you have the system acquisition, and finally the operation and support, which is the sustainment area. So for the international ISO model, the basic model is divided into 6 stages, and it has 25 primary processes. The processes are intended to represent a menu of activities that may need to be accomplished within the basic stages. Okay, so 6 major stages and 25 primary processes within the 5 stages. The ISO standard purposely does not align the stages and processes, but the 6 basic stages are the following. You start with the concept, move to development, to production, utilization, support, and retirement. So on the previous model, we don't have a stage denoted for this retirement phase or disposal of the equipment. In this one, that's taken into account. You see that the first 3 are kind of the same. Utilization and support can be operation and support in here. Operation and support. So there's some overlapping. And as I mentioned, then that last part of the retirement or disposal is not considered on the DoD. Questions? And then we have the professional engineer model. This is tailored to the development of commercial systems. This model is mainly directed to the development of new products, usually resulting from technological advances. So these are products that are technology driven. This is also partitioned into 6 stages, which are the following. You go from the concept, you find the technology. Is there any technology that we can use to make this happen? If that's the case, then we can move to development. Then from there, commercial validation and production preparation. So you start looking at who's going to be your clients and who are going to be doing the production of this equipment. Full-scale production, and then support. So even though they might have some differences in terms of the language being used to describe the steps, there's some overlapping between these 3 models. Okay, questions? So this is what we call the system engineering lifecycle model as defined by Korsiakov in our textbook. So this is the model that we are going to be using as part of the class. This is the systems engineering lifecycle model, and as you can see, has 3 major areas: concept development, engineering development, and post-development. Within the concept development phase, we have the need analysis, the concept exploration, and the concept definition. So it's all, as the title says, focusing on the concept that you want to put together to solve a problem. Once you have defined that concept, then we move, okay, this is the idea, these are the functions, these are the requirements, this is what the system must do in order to be achieving the performance that we are expecting. Then we move to the definition of the technology that we are going to need to make this happen. And that's where we move to the engineering development. So advanced development, the engineering design, and then the integration and evaluation. Evaluation, you can guess what's going to happen there, right? We want to look at the interfaces. We want to make sure that we test the environments. We perform tests for the system within the environment, and making sure that the system is going to be performing as expected under different conditions. Then, if we are sure that that's going to happen, then we're going to have an idea of how the production needs to look like in order to produce this new system. Okay, so for instance, when we talk about Tesla, when they came up with their first electric car, they were planning to, and they wanted to put that into production. They wanted to try to use some of the facilities that were open in the Detroit area, for example, to somehow reuse some of the installations, some of the machines to produce their cars. What they found out is, since the system was different, the actual layout or the actual production setup that were in place for gas cars was not feasible for their cars. So they needed to come up with a new production environment in order for make their cars. And that's what we are defining here. So can we use a current setup? Let's say you have multiple product families in your company. Let's say you work for Tylenol, or Johnson & Johnson produces the Tylenol. So you're working for Johnson & Johnson, and you are in charge of producing Tylenol. And then you have come up with a new pharmaceutical or new product that you want to put into production. Can you use that same manufacturing environment, or do you need to design something new to make that happen, to produce that new medicine? So that is involved here. It's not just designing the system, but also how do you manage the production environment to make that happen? And then once the system is in production, going back to the example of Tesla, so you have now those electrical cars. Who's printing? I'm going to stop the. Yeah, you can use the machine, but not. Please don't print. It's I'm teaching now. Yes, you're not supposed to be here right now. So you can use the machines, but this is interrupting my class. Okay. So going back to operation and support. So now you have the Tesla car there, and you have to produce some type of environment that will allow you to connect those cars so they can be charged and they can be used, right? So in addition to plan for the production, you also have to provide that environment that will allow your system to keep working, keep running. So they have come on with these stations, and you can go online and find those stations for pre-charging that are for their cars. So this is the overall system engineering lifecycle model. The concept development stage, which is the initial stage of the formulation and definition of the system concept perceived to best satisfy a valid need. The second part, which is the engineering development, covering the translation of the system concept into a validated physical system design, meeting the operational cost and schedule requirements. And then the post-development part, which includes the production, deployment, operation, and support of the system throughout its useful life. Okay, so any questions? I try to give you a good overview of where we're heading to. Again, this is the life cycle model, 3 parts, and I encourage you to know this. Okay, for the exam, I might ask you to tell me what are the 3 stages and what are the phases within each one of the stages. Okay, so this is something that you need to know. And so today we have an activity that I want you to perform, but before we get into that, let's just dig a little bit into each one of these stages. So the concept development stage has the analysis and planning that is necessary to establish the need for a new system, which is what I was trying to do with the first part of your project proposal. I wanted to establish the need for a new system. What is that area that you're interested in that you think there's a need for? So if there's a need for it, then I want to develop something to address that need. The feasibility of its realization. Okay, maybe we can say, okay, we need housing in Mars. Okay, is that something? Well, probably in a few years that will be needed, but is that feasible? Can we achieve that at this point? Do we have the technology? Do we have the knowledge to achieve that? The specific system architecture perceived to best satisfy the user need. Is this going to be based on something that already exists? Is this going to be an improvement to an existing system? Or is this something that I'm going to create on its own? It's new, it's different. Nobody has created something similar to this. Okay, so the principal objectives of the concept development stage are listed here to establish that there is a valid need for a new system that is technically and economically feasible, to explore potential system concepts and formulate and validate a set of system performance requirements, to select the most attractive system concept, define its functional characteristics, and develop a detailed plan for the subsequent stages of engineering, production, operational deployment of the system, and finally to develop any new technology, calibrate the selected system concept, and to validate its capability to meet the requirements. Okay, so at this point again, you have identified this D. Now you want to know if it is feasible, and if you're going to be basing this on an existing system. So is there any new technology that will be needed to achieve that new concept that you are coming up with? So for example, when they were designing the hybrid, the Toyota hybrid, they wanted to have this new car that will give you some extra mileage, right? And they knew they needed to come with a new engine to make that happen. So they came up with this idea of having a hybrid system in which you have electric, you have batteries, and you have gas. That was a new idea. It was a societal need, right? We want to improve our gas mileage. We want to reduce the pollution. So it has a societal need. But you can base your new design, going back to the hybrid, in the existing cars. If you look at the car, it looks very similar to other cars. But still, you needed to develop some new technology to make that happen. In this case was the development of these hybrid engines, or the use of both engines within the same car. So that's what I'm trying to address here, to develop any new technology called by the selective system concept. It is based on the existing system. However, we are using some new technology to achieve that new system. Questions? Okay. So the second is the process, the engineering development stage, the process of engineering the system to perform the function specified in the system concept in a physical environment that can be produced economically and maintained and operated successfully in its operational environment. Okay, so the system engineer is primarily concerned with guiding the engineering development and design, defining managing interfaces, developing test plans, and determining how discrepancies in the system performance uncovered during the test and evaluation should be best rectified. The main bulk of the engineering effort is carried out during this stage, during the engineering development stage. So at this point, we have the need, we know what we want in terms of the specifications. Now we want to translate that into functions and technology. So the main bulk of the engineering effort is carried out here. The principal objectives of the engineering development stage are to perform the development of a prototype system, satisfying the requirements of performance, reliability, maintainability, and safety, and to engineer the system for economical production and use to demonstrate the operational suitability. So again, we have all these requirements, we have all these functions, we have a concept in mind. Now we want to translate that into technology, and we want to make sure that we can develop a prototype that will satisfy this, economical production and operational suitability. And then finally, we get to the post-development stage, which activities beyond the system development period require significant support from systems engineers, especially when anticipated problems require urgent resolution and encountered. So again, this summarizes in general what's going to happen throughout the life cycle. In the next lectures, we're going to go in detail and see, okay, how can we perform this stage? And then we're going to be linking this with your project. So that's the importance of the project. So we are going to be working in the concept development, explaining the concept development, and then you're going to apply that to your project. But in order to get you started, I want you to work on this on your own. This is going to be the lab for today. You're going to be working independently. And I want you to list a minimum of 5 events, actions that will occur during each stage of the system engineering life cycle model. And I want you to think about the development of a new commercial aircraft. Consider the evolution of the new passenger aircraft. I want you to go and look at those 3 stages and want you to list a minimum of 5 elements, actions that will occur during each stage of the system engineering lifecycle model. Okay, so you can just open a new Word document and list the 3 stages and list 5 activities for each one of the stages that are related to the development of a new commercial aircraft. Is that clear? Okay, so I'm going to open a link on Track. So once you are done, you can upload that into Tracks. You should have enough time. I mean, still it's 8:40, so we have enough time to go through this and discuss it. So I'm going to give you until 9 o'clock to complete this activity. Questions? Okay, so let me put that